Hello, chemists. Today we're going to do a type of stoichiometry called limiting reactant or limiting reagent. And the key to these is identifying that it's a limiting reactant problem. It's not always going to be said in the problem. And the way to see it is if you're given the mass of more than one reactant, because one of them, just like sandwiches or s'mores, or the ingredients of those is going to run out first. So just as always, we are going to write our balanced chemical equation first. So this is number 5 of our stoichiometry worksheet 3. And I'm going to write aqueous zinc chloride. I'll leave off the states of matter. So that's ZnCl2. And aqueous sodium hydroxide, and you might recognize this as a double displacement reaction because these two aqueous substances are going to mix, give sodium chloride and zinc hydroxide. Zinc has a +2 charge, so you need 2 hydroxides, and that will give a solid. To balance this, we're just going to put a 2 in front of the NaOH and a 2 in front of the NaCl. So the student doing this has 5 grams of aqueous zinc chloride and 2.05 grams of aqueous sodium hydroxide. It's actually not talking about the water there, it's talking about the salts, how much of the zinc chloride and sodium hydroxide are dissolved. So that's where we're going to start our problem. And so which one do we choose? And the answer is both. We're actually going to do the problem twice. And the key about this is to find whichever one is going to give us less is going to be our limiting reactant. So either zinc chloride or sodium hydroxide is going to run out first, whichever gives us less product. And the product we care about is zinc hydroxide. So we also have a special name for this. It's theoretical yield. That means the maximum that you can get based on these two reactants. So let's start with the 5 grams of zinc chloride. I'll pause the video in a few spots just to do calculations. And we'll say this many grams of zinc chloride is 1 mole of zinc chloride. And for every 1 mole of zinc chloride, that will give 1 mole of zinc hydroxide. And then we'll convert the molar mass of zinc hydroxide. I'll pause the video and I'll have the molar masses written in. After putting in the molar mass of zinc chloride, 136.29 grams per mole, and the molar mass of zinc hydroxide, 99.41 grams per mole, and multiplying this expression, we get 3.64 grams of zinc hydroxide. So now this is not our theoretical yield yet. We don't know. So we have to check and see, well, how much is the yield going to be from 2.05 grams of sodium hydroxide? So we'll start there. 2.05 grams of sodium hydroxide. The molar mass of that one is 40.00 grams per mole. The mole ratio here is for every 2 moles of NaOH, we're going to form 1 mole of zinc hydroxide. And every 1 mole of zinc hydroxide is 99.41 grams, same as before. And we get 2.55 grams of zinc hydroxide. Now the question is, which of these is the theoretical yield? And the limiting reactant is always going to be the one that runs out first, so it'll provide less product. So this is our theoretical yield, and this one is meaningless. That mass would only come if I had a lot more sodium hydroxide. But because we started with 2.05 grams of NaOH and it gave a lower mass of final product, we know that the limiting reactant is NaOH, the one that gives less. So this one, zinc chloride, is the excess reactant. Now, there's going to be some left over. I'm not asking you at this time to find out how much left over, but that could be down the road. So this part right here is, well, what if I actually do the lab and get 2.25 grams? We call this the experimental or the actual yield. So to find the percent yield, we're going to take the experimental or actual amount that the student found, put it over the theoretical, which we just calculated, multiply by 100 to make it a percent. If we type all that in, we'll get 2.25 over 2.55 times 100, and that equals 88.2%. So just to review, we did the calculation twice, once with each of the reactants and their starting masses, found out which one is going to give less product. The one that gives less product, it comes from the limiting reactant. It's called the limiting reactant because it runs out first and gives less. And this other amount, the bigger one, is meaningless because you could only make that if you had a lot more of the limiting reactant, which we don't. And then after we find that theoretical yield, we'll take the amount that was actually made in the experiment, put that over the theoretical times 100, and that will give us the percent yield. Good luck as you try these on your own.